Okay, the first 4 or 5 minutes of this video, you don't really need to watch. It's just to prove to you why you're allowed to use what I'm going to show you how to do at the end. We're going to try to figure out the velocity. Oh, well, it's going to be nice if I pick a color that shows up on black. We're going to try to find the velocity at B, right? And I'm going to show you that right now. You know that if you're doing velocity, you need to use your kinetic energy equation, right? 1/2 mv squared. Problem is, while we do have mass, we don't have our energy, right? And it's kind of more difficult by the fact that this isn't the bottom of it, right? So 100% of our energy at the beginning, our mechanical energy initial, is 100% what? Potential energy. Now, if we were at the very bottom, like right here or right here, this would be our mechanical energy would be all be kinetic, right? We would know that our kinetic energy be equal to the potential energy at the beginning of the problem, right? The potential energy initial, right? Does that make sense? But since we're not completely at the bottom, we don't have 100% conversion at B, right? So right here, our mechanical energy at B is our potential energy at B plus our kinetic energy at B, right? And so this gets kind of complicated. So I'm going to show you what happens here. I do know, though, that these two mechanical energies have to be equal to each other, right? So that's going to tell us something. So let's figure out what our MGH here is at the beginning, and it'll tell us our energy budget for the entire system. Okay, so our M is 50. Our gravity, we're going to go ahead and use 10. Make that a little bit neater. And our height is 72 meters. 72. And we end up with a total of 36,000 joules like that if you put it in the calculator. So this kind of tells us how much energy we have total in the system. So over here at A, it would still be 36,000 joules, but we have more potential than kinetic. And at B, it looks like about half and half, right? We could just guess that, right, just from knowing that it's halfway down. But let's actually do the math now. So all I know overall, we're going to start simple and then we're going to expand a little bit. Our mechanical energy initial has to be equal to the mechanical energy at B. Okay, I'm going to work kind of faster. Don't worry about this part. I'm going to show you a shortcut in the last 2 minutes of this show. Okay, so our mechanical energy at E was potential energy, right? Potential energy initial was our mechanical energy at B, because this was 100% here, right? Okay, so let's expand it. MGH at initial is equal to potential energy plus kinetic energy. And let's look here. We have potential energy we can calculate because we have a height here at B. We still have our mass, and we still have gravity. So algebraically, I can do something right here. How do I get rid of potential energy? Well, it's adding, so I want to subtract it. Potential energy B goes away, right? So we'd have our MGH initial minus MGH at B, because potential energy is just equal to MGH, right? So now we have kinetic energy is 1/2 mv squared. Okay, so check this out. What can I algebraically do if I have two of the same thing when I'm subtracting? I can do this little thing called factoring and take out an mg from each one of these, right? So if I do that, it says mg h initial minus h b. So you see why, if you're not really savvy at algebra, why I said just, skip this part, don't worry about it. But I'm just showing you why the shortcut I'm going to use works, okay? Now, how do I get rid of this stuff over here? Would I get rid of the 1/2? We already know this. This should be familiar territory. Times 2 mg h initial minus h at b. These are heights, right? The difference of the height is equal to mv squared. How do I get rid of the m? Divide by m. Now look what's going to happen here. M cancels out, right? Now we have 2g height initial minus height b equals v squared. And now look what's going to happen. How do I get rid of the square? Square root. And now our equation should look very, very familiar. This is what we were doing to figure out the v in today's quiz and the day before. So you don't need to know how to do any of this. I'm not going to make you do this algebraically. You can just take this problem and you can redraw it like this. Okay? we are going to draw a new ramp with the difference in the height only. Because you see, the only thing that we did that was different from the equation we were calculating the other day, instead of putting 2gh square root, is it's the difference in the heights, right, between the initial and b. So let's redraw it. What's the difference between 72 and 36? 72 minus 36. And if you're real savvy, you know that's just should be half, right? So let's see, 72 minus 36. Just making sure. So we can redraw this as if it were a ramp at 36 meters, right? Because we're just looking at the transfer of potential energy. All right, we still have a mass of 50 kilograms. And we are looking for the V final here, right? So now this just becomes a really simple potential energy is converted into kinetic energy, right? So let's go ahead and expand that. mgh is equal to 1/2 mv squared. Let's get rid of the 2 mgh is equal to mv squared. Let's get rid of the m, stop dividing. What's going to happen? 2gh is equal to v squared. How do we get rid of the square? Square rooting it. There we go. And so here's our final equation. 2gh equals v. And now, though, this h is going to, instead of having to subtract, we already did the subtraction earlier. This 36 is going to go in there. So the square root of 2 times 10 times 36 is equal to our v. And let's see what that comes out to. 20 times 36 square root of 720. We get 26.8 meters per second about, right? Cool. All right, so do you see what we did there? All this stuff right here is just to prove to you that we can use the difference in the height and just redraw this problem to make it simple, okay? Do this today. Don't do all this. This is maybe some stuff you do in AP Physics to show your work, but I think you could even just show that it's the difference of the height. You know, if you know this shortcut, it's good enough. All right, good job.